Welcome to sunny Los Angeles, California. We are here at the Los Angeles Convention Center for Rapid TCT. This is a really cool show full of some exciting technology, and we're gonna get to check it out together. But before we do, make sure you like, subscribe, and turn on notifications below to make sure you never miss a video. Let's get into it. Rapid TCT is a trade show, kind of like the big machining trade shows you've been to, but here you're not going to find a lot of CNC milling or turning machines. This is all about additive manufacturing. So here you're going to find everything from companies printing aerospace components out of titanium to the more hobbyist stuff, all the way up to companies who are producing anatomically correct human body parts for training surgeons. A little bit of everything in between. We're going to take a look around here, see what the most exciting things are, and check them all out together. So one of the first things that caught my eye here was this Markforged Metal X metal printer. This was really cool because to me it still kind of functions in the same way that you'd expect a plastic or polymer 3D printer to work, but that's actually printing 17.4 stainless steel. Now, usually when you see these, they need to have lasers to melt the powder and all that kind of stuff. Instead, this is actually using a filament. And this has a wax matrix with that 17.4 stainless steel powder in it. And it's actually printing that out. So what you do with it after, when it comes out, it looks kind of like this. They call it a green part. That still has that wax matrix in there, but now it doesn't shrink. This is a different part that just looks the same. You wash and sinter the part, and when it comes out, it looks just like this. Now I thought this was super cool because not only can you do 17.4, you can do copper, just like this here. You can do A2, D2, H13 tool seals that you can then take and harden just like a normal part. Now here's the thing, I feel like 3D printing and additive machining has got a bit of a bad rap over the years. You know, I've said it myself sometimes. At first it seemed like a solution in search of a problem. Now the space is maturing, we're seeing a lot more applications for it that make sense. I mean, we just visited a shop today that has more automation than I've seen in a long time doing CNC machining, and they're printing fixtures, they're printing gripper jaws for their robots. There's a lot of applications that are realistically applicable to your average machine shop. And then when we get into some of this stuff, you're gonna see stuff that's applicable to very, very large machine shops. You can see that's actually 3D printing. I don't know what kind of component that is, but you can see that thing is only limited by how high that robot can go. So the workpiece you can put on there must be ridiculous. One of the big benefits of additive that you keep seeing out there is if you were gonna make this out of a normal, or if you're gonna make it on a normal CNC machine, you would have to start with a block of aluminum this big and mill it down. It's a lot of waste. It's gonna be heavy because that's gonna be solid. In this case, this actually only has 1 inch thick walls and the interior of this is hollow. So you're saving time, you're saving money, and in applications like aerospace or where you need to have a lightened part, you can literally shave half of the weight off this thing because there's nothing inside. And over here at the 3D Systems booth, I spotted these chairs. They look pretty hollow, but you'd be surprised how strong these things are. I was talking to them earlier. We're gonna take a look at the machine that did this, but this is only about a 10-hour print per. This is one that they designed here, and this is one that's actually done in one single layer that takes about 8 hours to print each. This is actually a pretty cool machine because instead of using a filament reel like others do, this actually uses a pellet hopper. It's essentially injection molding that same kind of material into that nozzle. So you're getting a very, very fast print time on there. And you can see that I think has a about a 3mm nozzle on it. Really, really neat stuff. You're seeing these go into machine shops for a lot of fixturing applications, aerospace applications. So if you're looking for something that can print extremely quickly, you're gonna wanna look at one of these, I think. So I know that you guys have probably, if you've watched our trade show coverage before, you've seen Meltio. It's a really cool company that puts additive heads inside milling machines so that you can do hybrid manufacturing right in your standard VMC. One thing that I saw that they're introducing here, which was really cool, is again, one of these giant robots. So instead of an application where you're actually mounting the head inside your mill, This is mounted on a robotic arm, and then it also has a 5-axis trunnion attached to it, so you can hit all those weird angles. Essentially, you can do additive as large as you can fit on there. I think that thing will go up to 800 pounds. I did hear there were some applications where they had jumbo robots that can hold up to 2 tons. So really, when you're dealing with this kind of stuff, you're limited not so much by the size of how big you want to make, it's just making sure that you can turn it around and actually be able to manipulate it like that. So you can see it's printing some really thin wall tubing there. It's 316 stainless. And essentially it's just stopping there to let that cool down. But you can see that head, it's feeding kind of like almost like a welding wire in there. Now again, one thing you always hear, or criticism I always hear, is what's the practicality of additive manufacturing? Well, you can make a propeller like this in 45 hours, but the print cost just for the material was only 300 euros. There's a lot of ways to do stuff like this, but giving yourself the capability to do something like this, say in a 3-axis mill or a 5-axis mill, it's just adding another tool in the toolbox. This may be one of the more efficient ways to do it. You have to give it a shot. Now here's something that I haven't seen before that I thought was really cool. This is the Array automated 3D printer. So much like in CNC machines, how you'll have pallet changing and pallet pools, this thing actually has 1, 2, 3, 4 3D printers going at the same time. What makes this cool is much like a pallet changer in a CNC machine, it's gonna go grab with that loader, pull that tray out, and go put it over there, load another build tray and put it up. So essentially you could have this thing running all night, you can have it running for 3 days. You're getting a lot more out of it. And these guys are actually out of Toronto, Canada, much like me. So I thought this was really cool. And of course, show wouldn't be a show without DMG Mori. Right now I'm joined by Corey.
Hey.
Now what is this? I haven't seen this before.
This is new for us. We've been working on it for a while. We're very excited to finally debut it. It is a 3D scanner that exists inside your tool carousel that you can swap into the machine while you're building a part.
Just like a tool. That's an HSK holder, it looks like.
HSK 63 holder, exactly bringing it in on a tool change as if it were an end mill. Fundamentally, it sort of encloses the entire ecosystem of your machining environment. We love the idea that, you know, DMG Mori has been making machine tools for 150 years, right? We think we're pretty good at it. At some point, we've got into additive on the DED side by adding fundamentally a laser welder to it. So that gives you a lot of options in that environment. And then adding the scanner sort of brings in a metrology element to allow you to sort of make some decisions at the lower level. This is a simulated example of something that would be, say, something like a press mold or a mold cooling tool, something like that. It's gotten damaged, it needs repair, it's worn. So we machine that away, we laser weld on it with either the same material or a hard-facing material. You machine that back to nominal, and in a typical workflow, you would then take the part out of your machine, walk it down to the quality control lab, put it on their shelf for a couple of weeks, and eventually they'll decide whether they like it or not, or it needs to come back to you. And if it comes back to you, you're going, I haven't seen this part in a month, I don't know what you want me to do with it. By allowing this ecosystem to exist with the 3D scanner, you can swap it in on a tool change, scan your part. What will come up is a deviation analysis, hopefully in all greens, to decide that you like the part, it can come out of the machine. If not, if you're seeing some blues and reds in your deviation analysis, you say, no, I got some more work to do. Maybe you weld on it again. Maybe you cut on it again. Maybe you, whatever, you know, you get it back into your CAM program and do some more work. One of the things that I absolutely love about this system, when you scan something, your origin exists sort of somewhere in space. And then you take that STL data, that tessellated mesh, you bring it back into whatever you're going to do your analysis in, and you have to play the alignment game.
Good luck.
And so the coolest part about this is when you decide that this comes in on a tool change and you're going to scan it, then that exists, that origin exists at your G54, at your machine coordinate system, well, your work coordinate system. NX calls it the MCS, the
right.
WCS. And then you're going to take that into your NX environment, your CAM environment, you're going to plan your welding path, you're going to plan your machining path, and you're going to bring that G-code back into the machine. there's no translation of where that origin is. It's all exactly where you left it.
It's still in the vise.
It's still in the vise.
You could literally take, apart from down the road that got busted, I have no CAD for it, no nothing, slap it in, run this, like you say, get my data, re-weld it, remachine it, scan it again to make sure it's right, and then away you go.
That's exactly right.
So there you have it, guys. Thank you very much for checking out Rapid TCT here in California with us. If you found this interesting, next year, this show will be in Detroit, so make sure you check it out. And as always, make sure you like, subscribe, and turn on notifications below to make sure you never miss a video. And now, it's party time.